Today we will learn about the Pythagorean theorem. In words, the Pythagorean theorem is that if a triangle is a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse of the right triangle. So, if we want to do this in terms of a formula, we would have a squared plus b squared equals c squared. A and b, or the two shorter sides, which are on either side of the right angle, are going to be your legs. We're going to square the length of each of these legs and then add them together. The sum is then the square of the hypotenuse, so the square of the longest side. In order to get c, or the hypotenuse, you have to take the square root. So let's look at some examples. So the first example is a 3, 4, 5 right triangle. In this case, the first leg has side length 3, so a squared is 3 squared, or 9, and the second leg has a length of 4, so 4 squared is 16. Now, when we add those together, we get 25. Now, on the right side, we start off with the hypotenuse c squared. So 5 squared is 25. Since 25 is 25, we know that we have satisfied the Pythagorean theorem. In the previous example, we used the Pythagorean theorem, a squared plus b squared equals c squared, to solve for the hypotenuse c. However, what if we want to find the length of a leg? So let's try that out. If we want to get a squared by itself, we need to subtract b squared. And whatever we do to one side, we have to do to the other. So a squared is equal to c squared minus b squared, or the difference between the squares of the other two sides, the hypotenuse and the other leg. Now, just like before, where we said to get c by itself, we have to take the square root, we also have to take the square root to get a by itself, because the opposite of square is square root. So that leaves us with a is the square root of c squared minus b squared. Now, what if we wanted to do the same thing for b squared? Well, to get b squared by itself, we're going to have to subtract a squared from each side. We are left with b squared equals c squared minus a squared. So pretty much the same thing we had above. We're going to have b equals square root of c squared minus a squared. So whenever we want to find the leg length, like here where we have b, what we're going to have to do is we're going to have to square the hypotenuse and the other leg. So 10 squared is 100, and 24 squared is 576. Then what we need to do is we need to subtract those. So find the difference between the two. In this case, 576 minus 100 is going to be 476. We need to take the square root of a square, and those two cancel out, and leave us with b is equal to the square root of 476. If we type this in the calculator and round, we will get that b is about 21.8 units. Looking at the next example, we are going to try to find c. So we need to use the Pythagorean theorem as it's written. A squared plus b squared equals c squared. Now, a squared, or 12 squared, is going to be 144, and b squared, or 35 squared, is going to be 1,225. When we add these two together, we get 1,325. 1,369. Since we have c squared and we want c, we will need to cancel out the squared by doing the inverse, by taking the square root. So the square root of c squared is just c, and the square root of 1,369 is 37. Now we'll learn about the converse of the Pythagorean theorem. So we said that if a triangle is a right triangle, the Pythagorean theorem is true. So a squared plus b squared equals c squared. However, the converse, or the other direction, is also true. If the sum of the squares of the lengths of two sides of the triangle is equal to the square of the length of the third side, the triangle is a right triangle. In formula, this would mean if a squared plus b squared equals c squared, then ABC is a right triangle. For example, here we have the side lengths 5 and 12, and if we square both of those, we get 5 squared is 25, and 12 squared is 144. Then we have on the right side 13 squared, while 13 squared is 169. If we add 25 plus 144, we do get 169. So, since the two sides are equal, we know that this triangle has to be a right triangle. Let's look at another example. Is a triangle with side lengths 11, 6, and 5 a right triangle? Well, let's take each side length, 5, 6, and 11, and square them. 5 times 5 is 25, 6 times 6 is 36, and 11 times 11 is 121. Since 25 plus 36 is not 121, we know that this is not a right triangle. However, what kind of triangle will it make? In order to figure this out, we need to know two more things. First of all, square of the hypotenuse being greater than the sum of the squares of the legs, like in the example to the left, means that we have an obtuse triangle. For acute triangles, the square of the hypotenuse will be less than the sum of the square of the legs. Now let's look at this example on the right. Is the triangle with side lengths 12, 20, and 16 a right triangle? Well, first of all, we need to find the square of each side length. In this case, the side length 12 squared is 144, 20 squared is 400, and 16 squared is 256. Since the two smaller sides added together gives us 400, we know that the two sides are equal and we do indeed have a right triangle.